Hello everyone, I am Dr. VRAO. In the last class, we had gone through the concentration cells and we came to know that concentration cells are two types. One is electrolyte concentration cell and another one is electrode concentration cells. And in the last lecture, that is in the lecture 47, we had gone through the concentration cells, that is electrolyte concentration cells, and we derived an equation for EMF of electrolyte concentration cells. Okay. So, in this class, we shall derive an equation for EMF of electrode concentration cells. Before we are going to derive an equation for EMF of electrode concentration cells, let us see or let us know what is electrode concentration cell, right. Electrode concentration cells. Right. In these cells, potential difference is developed between two similar electrodes dipped in same solution of electrolyte. I repeat, in these type of cells, potential difference is developed between two similar electrodes dipped in same electrolyte solution. For example, if you take hydrogen electrodes, two hydrogen electrodes at two different pressures or two different or at two different gas pressures dipped in HCl solution constitute the cell of electrode concentration cell. I repeat, if we take two hydrogen electrodes at two different gas pressures dipped in same solution of hydrogen chloride or dipped in hydrogen chloride solution, that constitutes the cell of type electrode concentration cell. Okay. That is, if we take hydrogen electrode, platinum H2 gas, let us pressure be the P1 at this electrode. This electrode is dipped in HCl solution of molarity 1 molar, right, and in the same electrolyte another hydrogen electrode, that is H2 gas maintained at pressure P2 PT. Okay. So, this is this type of this is the example for electrode concentration cell, right. So, in this this is hydrogen electrode and this is also hydrogen electrode, and this electrode maintains at gas pressure P1, atmosphere pressure P1, and this hydrogen electrode maintained at pressure P2. So, these two hydrogen electrodes are different, are maintained at different concentrations, are maintained at different gas pressures, and that two electrodes are dipped in same solution, that is that two electrodes are dipped in hydrogen chloride solution, HCl solution of 1 molar. Right. This constitutes the electrode concentration cell, right. Now, we shall derive an equation for EMF of the electrode concentration cell. So, what we should do before we are going to derive what is it called EMF equation, we should know, we should write electrode reactions. This is anode. We know that left hand we usually we write anode at left hand and cathode at right hand. At anode what takes place? Oxidation takes place. anode, in this at anode hydrogen gas undergoes this is at pressure P1, undergoes oxidation, that is loss of electrons, 2H plus 1 2H plus 2 electrons. So, this is at 1 molar concentration, right. This is takes place at anode, and at cathode reduction takes place, that is 2 H plus ions of 1 molar undergoes reduction, that is 2 electrons and gives rise to H2 gas at pressure P2 So, the net electrode net cell reaction is this cancelled out, and the net cell reaction is H2 gas at pressure P1 gives rise to H2 hydrogen H2 gas at pressure P2. Okay, this is the net cell reaction. Okay, this is the net cell reaction, and we can apply for and for this reaction we can apply Nernst equation. Okay, Nernst equation can be applicable to cell reaction and single electrode reactions also. Here is the this is the net cell reaction. So, we can apply Nernst equation, that Nernst equation is E cell is equal to E naught cell minus 0.059 by n log here is the reaction. We can apply the this is log K, and we can write equilibrium constant, that is K value, that is P2 by P1, because H2 here is the H2 gas maintained at pressure P2, and this is the H2 gas maintained at pressure P1, right. So, this is the equation, and we know that for concentration cells E naught cell always 0, right, and we and from the lecture 47 we came to know that E naught for concentration cells E naught cell is 0 for concentration cells. So, we can write 0 for this minus 0.059 by n is where number of electrons involved, that is 2 log P2 by P1. Okay, this is the equation, and in the next step it turns that is E cell is equal to already E naught 0, and this becomes 0.059 by 2 log P2 by P1, right, and we can write this as 0.059 by 2 log P1 by P2. Okay, ulta, that is I am changing the denominator and the numerator. Okay, I am reciprocal that fraction, so that we can eliminate this negative sign. So, E cell is equal to 0.059 by 2 log P1 by P2. Okay, and E cell is equal to, in general we can write E cell is equal to 0.059 by n log P1 by P2, log P1 by P2. So, this is the equation for EMF of electrode concentration cell. Okay, so and we know that EMF of a cell is linked to free energy of the reaction. Okay, and that free energy determines the spontaneity, and free energy determines the spontaneity of the reaction. This for example, if E cell comes out to be positive, then delta G becomes negative. If delta G is negative, then that reaction is spontaneous. Okay, so here for E cell to be positive, P1 is greater than P2. For E cell is to be positive, P1 is greater than P2, then E cell becomes positive. Then E cell becomes positive. E cell becomes positive. Whenever the E cell is E cell positive, delta G becomes negative, because E cell and Gibbs free energy are related by the equation minus NF E cell. If E cell is positive and delta G becomes negative, and that delta G negative means that is a exothermic reaction, and that reaction on the cell reaction is spontaneous. Right. So, in this way we can derive an equation for EMF of the electrode concentration cells. So, we discussed that electrolyte concentration cells and electrode concentration cells, and we derived the equation for EMF of electrolyte concentration cells as well as electrode concentration cells. These are the very important concepts, right? And in the next video I shall come up with another concept. If you really like this video, you please extend your support by like, share, comment. Thank you for watching.